So down the group, electronegativity decreases, correct, because down the group we are moving towards the metal. We know that metals, they will lose electrons, correct, and they will become positively charged. So electropositive nature is for the metal, right, and nitrogen, it is a non-metal. It will gain electrons and become negatively charged. Therefore, moving down the group, the electronegativity decreases. So let's discuss about the melting point and boiling point of group 15 elements. So here I have mentioned the melting points and boiling points of group 15 elements in Kelvin. So you can see that from nitrogen to arsenic, correct, the melting and boiling points, it is increasing. Generally, if we speak, down the group, melting point and boiling point will increase. Why it will increase? Because atomic mass also increases, correct. So MPBP will also increase. But here an exception is also there. Nitrogen to arsenic, melting and boiling point increases, but if you see for antimony and bismuth, correct, see the numbers 904 and 544. So the melting point and boiling point for bismuth, it is less than antimony. Now what is the reason for this? Why it is less for bismuth than antimony? So see the electronic configuration. Antimony, it is having 5 electron shells, correct, up to 5 it is filled, so 5 electron shells. Bismuth, it has 6 electron shells, correct. Now in antimony and bismuth, you can see that d orbital is present, and in bismuth F and D both are present. Now we know that F and D orbitals, they provide poor shielding effect, correct, they provide poor shielding effect. Therefore the s electrons, two electrons are there in s orbital, they will be attracted towards the nucleus. The force of attraction is more, correct, and only 3 electrons are available for bonding. Only 3 electrons are available for bonding. Therefore, bismuth will form 3 bonds. It will form 3 bonds, correct, and this is also called as inert pair effect. S electrons, they are not taking part in the bond formation, so it is also called as inert pair effect, right. I'll repeat it. It is F and D, they provide poor shielding effect. Therefore the s electrons, they will be attracted by the nucleus. So the s electrons are not ready for bond formation. Only the electrons in p orbital, they are ready for the bond formation. So bismuth will form 3 bonds, correct, only 3 bonds. Suppose if inert effect is not shown by bismuth, okay, then all the valence electrons, the 5 valence electrons will be available for bonding. Then it will form 5 bonds. Now think 3 bonds are there, 5 bonds are there. Which will be weak? Very weak. 3 bonds. Correct. More the number of bonds, it will become stronger. So here only 3 bonds are there. Because of this, the force of attraction between 2 atoms of bismuth is less. Therefore, bismuth has less melting point and boiling point. Hope you understood this, why the melting point of bismuth is less than antimony, also the boiling point. So let's discuss about the ionization enthalpy. Ionization enthalpy means the energy required to remove an electron. Now check the ionization enthalpies first, second and third. So you can see the trend in the first ionization enthalpy, it goes on decreasing. Why it goes on decreasing? Because as the number of shells are increasing down the group, the valence electron, it is loosely bound. There is no force of attraction from the nucleus, right? Therefore, it can be easily removed. But when it comes to second ionization enthalpy and third ionization enthalpy, you can check here the trend. From nitrogen to arsenic, it decreases, both second and third ionization enthalpies. Nitrogen to arsenic, it decreases. Antimony to bismuth, it increases. See the trend here. Antimony to bismuth, it is increasing. So that is what I have written over here. The second ionization enthalpy and the third ionization enthalpy of bismuth is higher than antimony. So again the same reason like that of the melting point and boiling point. The ionization enthalpy of bismuth, that is the second and third ionization enthalpy of bismuth, is higher than antimony. So what is the reason? See the electronic configuration of bismuth. 4F14, 5D10, 6S2, 6P3. Again, we know that F and D provide poor shielding effect. Moreover, F over here, F orbital, it is completely filled. Right? So, the outermost electrons, the valence shell electrons, they are strongly attracted by the nucleus. Why they are attracted? Because F and D provide poor shielding effect. And because of this reason, the second and third ionization enthalpies of bismuth is higher than antimony. If you see the electronic configuration of antimony, F orbital is not present, only D is there. Correct. If both the orbitals are present, means they will provide more poor shielding effect. But in antimony, only D orbital is present. Right. So, comparison if we do, bismuth has F orbital and D orbital, which will provide a very poor shielding effect, because of which the valence electrons, that is 2 and 3, they are attracted towards the nucleus and more energy is required to remove that electrons.